In this lesson, we are going to learn how to solve logarithmic equations. We're going to work in section 10.7 of your book on page 859, and we will work problem numbers 2 through 16 even. So let's go ahead and look at problem number 1. I'm going to start actually at number 1, so I'm going to change that 2 to having a 1 and 2 through 16 even. Number 2 is a little tricky. So we have log 5 of x equals 3. So remember, I believe in section 10.5 we learned how to translate these logarithms to have it just as exponents. So you take this base of 5 here. Your exponent of 5 is going to be whatever your logarithm is equal to. And then you set that equal to your x right here. So to figure out what x is, you take 5 to the third power, which means 5 times 5 times 5, which gives you 125 equals x. So number 2, we have log base 3 of x equals -2. So you take your 3 as your base, your -2 is going to be your exponent on this problem, and then that all is equal to x. Remember in section 5.2 video, we learned how to work with those negative exponents. Remember, in order to make an exponent positive, you take it and move it to the other side of the fraction. So since it's in the numerator right now, we're going to move it to the denominator. That's how our exponent becomes a positive. And then you've got to have something up here. You can't just have it blank, so we put a 1 as a placeholder. And then 3 squared gives us 9. So our answer to this problem is 1 over 9 equals x. Okay. Problem number 4, we have log base 5 of 3x plus 2 equals 3. So I'm going to go ahead and put my 5 as my base, 3 as my exponent, and set that equal to the 3x plus 2. Before we can get the x by itself, you've got to find out what 5 to the third power is first, which we know is 125. And then you got to take care of your addition and subtraction first. That's how we get rid of that. And then divide each side by 3 to get 41 equals x. Okay. So now let's look at number 6. On number 6, we have log 5 plus log x equals 2. So remember, if there's no base written, so there's no subscript written right here, then we're going to go ahead and say that it is a 10. So remember, if your base is not written, it's going to be a 10 down here. So before we can go ahead and write this, then we need to write this as a single logarithm. So to do that, we write our log base 10. And since we're adding these two when it's in expanded form, to write it as a single logarithm, we're going to be multiplying them. So now I'm going to take my base of 10, raise it to the power of 2, and then equals 5x. So now 10 squared is 100. And then to get the x by itself, we're going to divide both sides by 5 to get 20 equals x. Problem number 8 says that I have log base 4 of x minus log base 4 of 8 equals 6. Oops. Just make sure I wrote that right. It's equal to 3, not 6. Okay, so again, before we can work this problem out, we need to go ahead and write it as a single logarithm. Okay, so if you need help on writing them as single logarithms, then you can refer back to section 10.6 video. So you write log 4 here, and instead of writing x minus 8, remember when you're subtracting, that's your quotient rule, you're going to be dividing those. So we're going to take our x divided by 8 equals 3. So to write it as an exponent, we would put 4 to the third power equals x over 8. So 4 to the third power is 64. And then in order to get that x by itself, it's being divided by 8. So the opposite of dividing by 8 would be to multiply. So that's how we can get that 8 to cancel. And then 8 times 64 is 512. And that's your answer. Okay. So now let's look at problem number 10. Actually, I'm going to need a little more room than that. So in problem number 10, we have log 3 of x plus log 3 of 2x plus 3 equals 2. So we need to write it as a single logarithm first. So we would put our log 3 one time, and then since these are being added, you're going to multiply these two. So you would multiply your x times your 2x plus 3 equals 2. So we're going to take our 3 as our base and raise it to the second power and set it equal to x times 2x plus 3. So 3 squared is 9, and we can go ahead and distribute this x. So x times 2x is 2x squared. X times 3 is 3x. So now we've got a quadratic equation. And so if you learned how to solve quadratic equations through me, then I always teach you that if you've got an exponent of 2 in your equation, so a quadratic, then go ahead and move everything to the same side of that x squared. So we're going to subtract 9 from both sides to get it to move over. 9 minus 9 is 0 over here. And you can't combine this 9 with any of these terms because they're not like. So you just rewrite everything here. So now I'm going to go ahead and solve by whichever method I choose. My favorite way of solving quadratic equations is to factor. So I use my AC method. A is 2, B is 3, C is -9. So you put your 2x on top of your wings. 2 times -9 is -18. And then your 3 is down here. So you need to find out what multiplies to give you -18 and adds to give you a +3. So remember that since they multiply to give you a negative, one number is a positive, one number is a negative. So I'm going to choose the pair of 3 and 6, and your 3 is going to be the negative number. So always do your check. Does -3 times 6 give you -18? It does. Does -3 plus 6 give you 3? It does. So now, before we can write our answer, you need to simplify these. So this becomes a 1, and that becomes a 3. So we now have 2x minus 3 and x plus 3 equal to 0. And now we need to set each of those binomials equal to 0 to solve. If you are completely baffled by what the heck I am doing, then you can go to the section 8.2 video, or I'm sorry, 8.1 video, 8.1 video on how to solve by factoring, and that'll explain this whole ordeal. So now to solve, add 3 to both sides to get 2x equals 3, and then divide by 2 to get x equals 3 over 2. Then subtract 3 from both sides for this one to get x equals -3. Now guys, you cannot take the logarithm of a negative number, so any negative solution that we get, we're going to throw out. Okay, so your answer for this problem is going to be a +3 over 2. All right, now to move on to problem number 12. On number 12, we have log base 2 of x plus 2 plus log base 2 of x minus 5 equals 3. So we have to write them as a single log first. So log base 2 of x plus 2 times x minus 5 equals 3. So we have 2 to the third power, base and then to that power, equals x plus 2 times x minus 5. So 2 to the third power gives you 8. And then x plus 2 times x minus 5, that's distributing. So you take your x times all this and your 2 times all this. So x times x is x squared. X times negative 5 is negative 5x. 2 times x is 2x. 2 times negative 5 is negative 10. So now to combine our like terms, we have 8 equals x squared minus 3x minus 10. And then subtract 8 from both sides to get that equal to 0. Because remember, when we have a squared in there, we want to move everything over to that side. So you get 0 equals x squared minus 3x minus 18. And to factor that, you would get x minus 6, x plus 3. So now you would set both of those equal to 0. So you would set x minus 6 equal to 0, x plus 3 equal to 0, and solve. So this one would give you an answer of positive 6. This would give you an answer of negative 3. Remember, you throw out your negative solutions, so your answer is 6. Number 14 says that I have log 5 of x plus 5 minus log 5 of x equals 3. Oh, that's not right. Sorry, I'm getting a little cross-eyed trying to read these out of the book. Let me make sure I've got it right first. So log 5 of x plus 5 minus log 5 of x equals 2. Okay, so I'm going to write it as a single logarithm first. So log 5 of x plus 5 divided by x. Remember, when you see subtraction here, that means that you're going to be dividing them, equals 2. So you have your 5 as your base, 2 as your exponent, and then you set this equal to your 5 squared. So 5 squared is 25. And remember, we said that in order to get this denominator out of here, you can just multiply by it. So that's how those x's will cancel. But what you do to one side, you got to do to the other. So that gives us 25x equals x plus 5. Okay, so now we're going to subtract x from both sides because you got to get all your x's on one side. So you have 24x equals 5. And then you'll divide by 24 to get your solution. So you get x equals 5 over 24. Now I know that's not a desirable solution. It's not a beautiful whole number, but it is the solution. That is your answer. All right, so now let's move on to the last problem of this, number 16. On number 16, I have log of x plus 2 minus log of 2x minus 1 equals 1. So remember, if you do not have a base written, we're going to put a 10 there. So we're going to write it as a single log. Log base 10 of x plus 2 divided by 2x minus 1, and I use division because of that subtraction there, equals 1. So 10 to the first power equals x plus 2 over 2x minus 1. So to get rid of that denominator, I'm going to multiply by that 2x minus 1. That's how they cancel. So if I do it over there, I'm going to do it over here. So I'm going to say 10 times 2x is 20x. 10 times negative 1 is negative 10 equals x plus 2. Now I'm going to subtract x from both sides to get my x's all on 1. So that gives me 19x minus 10 equals 2. Then I'm going to add 10 to both sides to get 19x equals 12. And then divide by 19 to get x equals 12 over 19. Again, it's not a desirable solution, but it is our actual solution. That's all I have for you on this video. I wish you the best of luck, guys.